Hello everyone, welcome back to another Leetcode problem solving session. Today we're going to be solving problem 13, which is called Roman to integer. So Roman numerals are represented by 7 different symbols, I, V, X, L, C, D, and M. Here they have a table that represents what value each symbol is. So I is 1 all the way down to M is equal to 1000. So if you were to write 2, it would be written as II, as you can just add the two ones together. 12 would be XII because you would add the X and the II. Typically, you have it in descending order if you've never worked with Roman numerals, except there are a few cases, they say 6 instances that we're going to have to worry about here, where something that is so in this case, you'll see that I comes after the X because the I is worth less than the X. There are cases where the I would come before the X. There's 6 instances. One is with I coming before V or X to make 4 and 9. So IV would be like, so that's 1 and 5. But since the 1 comes before the 5, we now subtract 1 from the 5 to make it 4. And similarly with IX, you would subtract 1 from 10, since X is worth 10 from the table up here. So yeah, X can come before L and C will come before D and M. It is guaranteed that S is a valid Roman numeral in the range. So in the range of 1 to 3,999. So yeah, I think the most intuitive approach would just to be going through each character within our Roman numeral string if we had like XII, and just figuring out what we want to do with each of these characters. You can either add or you can subtract. So we're going to have 2 cases for each character that we look at. We're going to have to figure out whether or not we're going to be wanting to add or subtract each character. But first, what I want to do is make a mapping between the characters and the values. So I will map to 1. We're basically just going off this table that we have here. Map to 5. So now we have our table set up where we can simply pass in a character and get what value should this character represent in Roman numerals. So now what we're going to do is we're going to initialize our res to be 0. And eventually we're going to return our res. But in between that, we're going to go through each character in the string. I'm going to enumerate each character, so I'm going to get the index as well, and you'll see why in a second. But essentially what we want to do is check if the character after our current character is of greater value than our current character. So in this case, I comes before V, so the character that comes after our current character, a V, would be worth or a greater value than our I. Then what we're going to want to do is subtract our current character. So essentially what we need to do is check, well, 1, is there an X character? So if I plus 1 is less than len of S, and is the value of the next character greater? So Roman SI is less than Roman S. Sorry, I guess we can replace this with C. SI plus 1. So if that is the case, then we're going to subtract from our value, or our result. So Roman C. Else, well, now we know that either there isn't another character, so we're going to just simply be adding because whatever the current character is doesn't come before a greater value character. Or, like I just said, the character that comes next is not of greater value, so we're not subtracting, we're adding. So in that case, we can simply add Roman C. And then we should just be able to return our result once we've gone through every character. So just as an example, here we have that the I that comes after our current character is obviously not of greater value, it's of the same value. So we're going to jump to this else and add Roman I, which is just 1. And then we do the same for the next character, since the I that comes after it is not of greater value. And then there's nothing after it for the third I, so we add 1 again. So we add 1 3 times, that gives us 3, and we turn 3. For this, we add 50, since V does not map to a greater value than L. Then we add 5 for V, since I does not map to a greater value. And then we have the same thing that we had above here with the 3 I's. So we had 50 plus 5 plus 3 gives us 58. Here is where we'll get something different. M maps to a greater value than C. So we're going to add 1,000. C maps to a smaller value than M does. So we're going to subtract 100. So 1,000 is our current result so far. Just keep track of that here. 1,000. And then we have minus 100. That gives us 900. And then M is of greater value than X. So we add the M, which is another 1,000. And then the X is of smaller value than C. So we subtract 10, which gives us 1890. Then the C is of greater value than the I, which gives us 1990, because we're adding 100 to 1890. Then we check, okay, I is less than the V, so we're going to subtract 1, which will give us 1989. And then we add 5, because it's the last character in the string, and there's nothing after it that could be greater. So we get 1994, as we would expect. So just double checking that this actually passes those test cases and passes all test cases. There you go. So yeah, this was essentially just creating a dictionary that allows us to map the different characters to their values, and then looking at the cases where subtraction would be used and determining maybe a good condition to use to see if we are supposed to be subtracting, and subtracting in those cases, adding in every other case. But other than that, I think this is pretty straightforward. Obviously, O of n, time complexity, O of 1, space complexity. Even with this is always going to be the same size, so it is a constant thing. It doesn't vary with the size of our input, so we don't have to worry about having non-constant extra space. But yeah, oh, I just realized I have 2 return reses. But yeah, hopefully that makes sense. Please like and subscribe, and leave any comments to clarify anything from the solution, and I'll see you guys in the next one.